All right, I hope you guys can hear me now. Thank you for putting up with me. I forgot to turn my sound on. Hey, we're live. Welcome, everybody. Again, I've been talking for like 5 minutes and no one's hearing me. So, yeah, I hope you guys can hear me now. Sorry about that. Hey, my name is Tom Marsala. I'm a math teacher at Chavela Middle School. Shout out to my students and my fellow staff, also to my friends and my grandchildren who might be watching. Love you guys. Hope you're having a good day. So we are live streaming this from my backyard. It's really cool that we are able to do this in today's technology, to hook up a camera to a telescope and see things that 150 years ago were only thought and imagined. Just really quick, here's a picture of my setup. You can see my telescope over there. It's got a special sun filter on it to filter out the majority of the light so we can see what's going on. Please do not look at the sun today, to my students, unless you have a professional purchased solar filter from an astronomy store. The sun can burn your eyes very quickly. Please do not look. Do everything either through a pinhole camera, which you can make yourself with a piece of paper, or you can just watch what we're doing right now. So that's what my equipment looks like. Here's what's happening animation-wise. I'll show you a picture of what's happening here. This is a real-time animation. You can see that the moon right here is passing in front of the sun. Now, for those of you who think this is a scarce or a rare event, it's not really. The moon goes in front of the sun every month, between 29 and 30 days. But sometimes the moon is up here too high and sometimes it's too low. But there are times when the moon's path perfectly intersects the sun's path, or the sun's position, and we get an eclipse. What's really cool about this is that the sun appears to be the exact same size as the moon does. That's because the sun is 400 times bigger than the moon, but it's also 400 times further away. And so we get this exactly same size, about a half of a degree, in the sky. Now you may wonder, does that happen anywhere else? Well, let's check out an eclipse on Mars. Not very exciting, right? It's a rock going in front of the sun. Mars's moons are rocks, pretty much, not circular, not spherical. And so that's as good as it gets on Mars. It's cool, and yeah, the Curiosity rover actually took that picture, but not very exciting. For our friends in Idaho and Oregon, in about an hour, they're going to see this, and this is where we get the ring of fire idea. It's called an annular eclipse because that ring, which is Latin, in Latin is annulus, pops through because the moon isn't exactly the same size. It's a little further away in its orbit. The moon's orbit is not perfectly circular, so in this case, it just doesn't quite fit very well, and so we get this leftover ring, which is really neat. It's a beautiful event if you're up there in Idaho, Oregon, north from us, but we don't get that today. We just get a partial. If the moon perfectly fit over the sun, we get this, which is 100% total eclipse, and you'll notice that the moon fits so perfectly that you, for a few seconds, you're able to see some solar prominences, some solar flares, and this outer atmosphere called the corona. That's super important because 150 years ago, an astronomer named Charles Young actually took a picture of the spectrum of the corona and found that the corona is made of hydrogen and helium, mostly gases, which led us to understand the sun is producing mostly helium from hydrogen in a fusion reaction, giving us that light and heat that we love. So if it weren't for eclipses, we wouldn't know anything about the sun, and it's amazing that we on Earth are in the best platform to understand what's going on around us. Let me go back live right now and see what's going on in my camera. Bear with me for a second. There we go. Okay, I'm going to adjust this a little bit. This is live from my telescope. I'm going to try to adjust the aperture, so hang on a second while I do this. There we go. We're able to see some sunspots. I'll point those out. We're still in the tree line, so we're not really 100%. But now here you see the outline of the moon. And the moon is heading this direction. I'll try to animate that for you, but let me center. So hang on one second. Let me center it up. Here we go. Perfect. Now, I told my students yesterday, watching an eclipse is kind of like watching grass grow, or maybe more like watching the clock hands move on your clock. It's incredibly interesting, but it goes very slow. And the moon is moving. And I'm not talking about the normal east-west motion across the sky. I'm talking about in its orbit. What's happening is the moon is advancing over the sun and will block about 71% in about 45 minutes. But it's going to take that much time because the sun moves about a half a degree an hour, which is hard to see when you're watching, like grass grow. But if you come back in about 5 or 10 minutes, it will have moved. So let's see if we can zoom in on some of these sunspots and see what's going on. You guys can feel free to chat. Again, just keep it appropriate, please. That's for my students, by the way. Hold on one second. Hey everybody, it's good to see you. Can you guys hear me okay? Can someone on the chat tell me that you can hear me? Oh, okay, thank you. Good. All right, so let me do a couple of things real quick. Let me do some office work here, and I'll get back to you in a second. This is a still image. If you look really close, right about here, get my pen turned on here, you guys can see these spots here. These are sunspots on the surface of the sun. Those are actually magnetic storms that produce some of those solar flares that you were looking at on the other picture. Now, the sun is not really this red. I have no filters on my camera, on my sensor, which allows red light to really come through a lot. So you're looking pretty much at a very red, this is real time and real light, but the red is due to the fact that there's a lot of what's called hydrogen alpha wavelength coming through my camera. So you do get that reddish tint. But you'll notice here's the outline of the moon. In fact, the moon is up here. Let me put that in white, it might be easier to see. Here's the moon, and the moon is trucking this direction And that's the way it's going. This is backwards, by the way, as it really is happening in the sky because my telescope optics turn everything backwards. But it's really moving that direction. But it doesn't matter. So in a few minutes, in about 40 minutes, we'll see that the moon will eventually be somewhere here, and just allow the sun to peek through and give us that crescent shape right there. Let me go back to a live picture here and see how we're looking. There we go. All right, thank you everybody for the feedback. It looks like sound is good and stream is strong, so that's always a good thing when I'm outside. And shout out to Frontier for their internet working today. That's great. Let me enlarge this. There we go. So pretty soon, as the moon peeks over, you'll see these sunspots disappear. I do want to try to enhance this a little bit more for you. Let me know if there are any questions you guys may have on the chat. I'm trying to monitor the chat at the same time. I'm sorry I'm not getting to everybody, but thank you all for showing up. I appreciate it. But let me know if you have any outstanding questions or anything while we're doing this. My goal today is to get you through the maximum eclipse, which will happen around 9:30. So if you want to go grab another cup of coffee, feel free to do that, or a Diet Coke or something while you're drinking, and you can watch. But this will change very slowly over the next hour. Well, I'll go ahead and keep it at that brightness for right now. That looks pretty good. I'll go ahead and give you a full screen, which should help. Right now I'm in my backyard, and you can see my telescope right there. It's got a good view of the sun now. Sitting in the corner of the house where I can see the sun amidst my neighbor's palm trees. So had to be selective this morning. Now, we haven't had a total solar eclipse here in Southern California in many, many years. The path of the solar eclipse is really narrow. So right now that path is over Oregon and Idaho area. Those people up here, I know my son and his family live up near Boise, and so they're going to see probably closer to 90% or more. Happy birthday, son, by the way. You get an eclipse for your birthday. I like that. They're going to get mostly a 90% or so. And if you get to the right spot, you'll get that full ring of fire effect for the eclipse today. Actually, total eclipses are more destination events. People travel across the world to go to that path to see the total eclipse. So if it's through India, they'll fly to India with their equipment and do it that way. A few years back, if you remember, they're up in Oregon, you could go up there and see it as well. It was a total eclipse. I had a friend who went up with his son and was able to do that. I wasn't able to, but I sure would like to put that on my bucket list someday. Someone asked what my telescope model is called. This is a Celestron C6. It's a 6-inch telescope. It's a Schmidt-Cassegrain telescope. It's got a little mirror in the back, and it does a great job for the moon and the sun and for some planets. So I use it as my planetary buddy, mostly on a little kind of a one-arm bandit mount. which moves the scope and altitude and azimuth automatically. So right now it's automatically tracking the sun. I don't have to move it or anything. And they're relatively inexpensive. It's a great entry-level telescope. If you guys are interested in ever getting one, I would recommend it. And I do speak Celestron, so if you have any questions, you can always let me know. Looks like we're nearing 40% right now. Looks like someone took a big bite out of an apple. Yeah, it does kind of look like a red moon. Someone had commented. Remember, when you see the moon, as you guys are probably going to learn in astronomy pretty soon, that it's not a shadow of anything going across the moon's face. When you see a first quarter moon or a crescent moon, that's actually the shape of the moon's own shadow. You're seeing the dark side and the light side of the moon exist together. In this case, we're getting the sun blocked out, literally blocked out. It does kind of look like a crescent moon in a way, and it will even more and more as the moon blocks out the light. But in real time, you can see now we're approaching that first sunspot, it looks like. Let's compare that with the animation. There's a question about how long the eclipse will last. Since the moon moves about a half a degree per hour, as soon as from contact, first contact to last contact, about 2 hours. It takes about an hour for the moon to cover the sun, and then about an hour for the moon to get out. So roughly 2 hours. And that would be... it would have moved a full degree in the sky. And the moon moves about a half of a degree per hour in its orbit. So this is like watching the minute hand on a clock, or more like watching the hour hand on a clock as it goes across the face of the clock. But it is moving, and we are able to see the moon's motion as it goes across that sunspot. We'll see if we can enlarge the picture a little bit. Oh, that wasn't an enlargement. That was a reduction. All right, so here we are close up, and let's take a few minutes and watch how fast the moon actually does move as it crosses that sunspot. We're right now about 850 power right now. Yeah, good question. How often does this kind of eclipse occur? It varies. There are actual times called eclipse seasons where the orbits, which are all tilted a little bit with respect to the sun, mathematically line up, almost like getting a common denominator for fractions. Sorry, kids, I got to bring math into it. But as the orbits line up, usually every 3 to 5 years, we get some sort of eclipse, and it could be a partial, it could be a total. So it just depends. Right now you're looking at the moon just crossing, if you can see it, it's crossing that sunspot. It's going to be eclipsing it really, really soon. You can kind of see the wavy motion of the moon. That's the atmosphere. That's the air moving the picture around a little bit. The air actually is pretty still right now, and that's a good thing for us. Oh, someone said they got the telescope. Good to hear. Yeah. Let me know if you ever have any questions. I'll be happy to help you out. And usually with solar eclipses come lunar eclipses, moon eclipses. And that's when the shadow of the Earth crosses the moon. And that's when we get a blood moon, turns red. Those are a little more frequent, a total lunar eclipse, because we end up, the Earth's shadow is so much wider than the moon's shadow. So we're actually able to see more of it. Looks like it just went over the sunspot, disappeared. That's pretty good. Let's zoom out and see what's happening here. Come back out to normal size. There we go. So that sunspot is gone. We're focusing on this next one here pretty soon. Depending on the timing of the orbits of everything, of the Earth's rotation and the moon's orbit, eclipses can happen in the morning like now. They can happen midday, or they can happen in the evening, depending on where you live. Well, I don't have the actual. Someone asked how much bigger is the sun compared to the moon. The moon is only about 6,000. No, that's the Earth. The Earth is about 6,000 miles in diameter. I don't know my moon offhand. You can Google that. The moon is about 400 times smaller than the sun. That I know in diameter. But the sun is 400 times further away, and so it gives the illusion that they're the same size in the sky. And I happen to believe that that's by design, not by accident, that they're the same size so that we could discover things about our universe around us and discover that the sun actually converts hydrogen to helium in a fusion reaction. That has allowed science to progress exponentially quickly throughout these last 150 years. So some cool stuff from just observing an eclipse. All right, so a little updated information. The diameter of the moon is about 2,000 miles. The diameter of the sun is about 860,000 miles. So there's your ratio of about 400 to 1 right there. Once again, if you missed it, this is what people up north in Oregon and Idaho will be witnessing today in about 30 minutes. And that moon will go right in front of the sun and give you a ring or an annulus around it. And last eclipse we had was a total eclipse in Oregon, and it looked like this. And there's that outer atmosphere called the corona. The actual surface of the sun here is called the photosphere. And that's the brightness that we see. There's also a chromosphere, which is just outside the atmosphere of the sun. It's hard to see because the sun is so bright. So there's not much of the sun we can see except the surface until that moon blocks it out. And then that allows us to see a lot that's going on behind it. Question is, how many moons can fit in the sun? That's a great question. It's more than 400. In fact, it would be 400 to the third power. Sorry, I got to bring math into it again, but the ratio of the volumes is the cube of the scale factor. So if the scale factor is 400 to 1, then it would be 400 to the third power, which would be 64 million. So 64 million moons would fit inside the sun. It's pretty crazy when you think about it. And I know someone's going to ask about the Earth, so let me see if I can figure out how many Earths can fit in the sun. Yeah, so the ratio of the Earth to the sun is about 100 to 1. So that would be 100 to the third power. So about 1 million Earths would fit inside. Yeah, Mr. Pye asked, are there specific camera filters for the radiation for the sun, even without the corona effect? And the answer is yeah, absolutely. Right now, this is a very cheap filter. Again, going back to my telescope there with that little cover on it. Looks like foil. In fact, it looks a lot like a Mylar balloon cover to filter out the sun's rays. That just basically takes out about 99.9% of visible light. Most of it's reflected off. A good filter, though, would be what's called a hydrogen alpha filter, and it's composed in two pieces. There's a pre and a post filter, and they are very, very expensive. But that allows you to see in very, very small wavelength what the sun is doing, and there are great pictures of the sun. NASA uses them, and now they're available to amateur astronomers even. They're about $6,000 to $8,000 per filter, though, so they're pretty pricey. Definitely out of this math teacher's price range. If you look at the sun without special glasses, the sun will burn your retina. If you've ever held a magnifying glass up to a piece of paper and it burns really fast, or maybe you put a magnifying glass on a little ant or something. Not that I've ever done that. But if you've done that, you know how fast proteins can burn. So it can fry your retina like an egg. So you definitely don't want to look at the sun at all without any special filter. One way you can actually see the shape is if you look at the shadow of leaves on the ground. If you're outside and you look on the patio and you've got some leaves, or even the little holes in your blinds in the house will act as a camera obscura and you'll be able to see the crescent. I do hear the birds beginning to sing a little bit more. It is morning, so they're singing anyway, but the sky is beginning to take on more of a dusky look now that we're getting close to maximum eclipse here. So what time is it? 9:07. Yeah, so we're about 20 minutes away or so from this being the maximum eclipse. Yeah, telescope is strong enough to see Mars, for sure. I have several telescopes, and of course the bigger your telescope is in diameter, the more you can see. This is a little 6-inch telescope, so you can definitely see Mars. You can see the rings on Saturn. You can see the gas belts on Jupiter. It's great for the moon and the sun, but it's a great little telescope to have in the telescope collection. But yeah, bigger telescopes will reveal more, for sure. It's all about aperture, which is the size of the mirror, the size of the hole. And that will tell you how much detail you can see. Not necessarily power. It's not about magnification. It's about the size of the diameter of the lens. Oh, the question, how many telescopes does Mr. Marsala have? Well, let's see, including this one. I have 1, I have 2, 3, 4, 5. I believe I have 5. And each one serves its own purpose. This one is for what we're doing now, for solar and lunar eclipses. I have a little bit bigger one than this. It looks just like it, but it's about 9 inches. I use that for some planetary imaging. And then my great big ones I have for imaging deep sky stuff like nebulas and galaxies. Well, no telescope. The question is there a telescope that can look into a different galaxy? And it's probably not into one. Can you look at one? Yes, definitely. Let me show you a picture here of one of the galaxies that I have taken a picture of. So there's the Andromeda galaxy. So I used my bigger telescope to help me take a picture of that, and also a smaller camera lens to add some details for that particular galaxy. So you can see a lot that's going on. Can you get closer than that and see inside? Almost. The Hubble certainly can. The James Webb certainly can get inside and see stars blowing up, supernova and stuff like that. So yeah, we can get pretty close. Sadly, Aaliyah, I have never seen Pluto through my telescope. I could probably, if I knew where it was, I could probably take a picture of it, but it would look like a star. It's so far away. It wouldn't be that interesting. The further the planets are, the smaller they appear and the harder it is to get their image sharp enough. Someone asked how far that galaxy was that I showed you just a few minutes ago. That is about 2.5 million light years away. The Andromeda galaxy is one of our closest neighbors. It's a very large galaxy, and it covers a big portion of the sky. It means it takes light about 2.5 million years to get to us from there, which is crazy when you think about it, because you never look at the present when you're looking at the sky. You're always looking in the past. For example, right now the sun is 8 light minutes away from us. So as you're seeing the sun right now, you're seeing it as it happened 8 minutes ago, not now. The moon, by contrast, is 1 light second away. So we're seeing the moon as it appeared 1 second ago, which isn't too far in the past, but it's definitely in the past. Because light has a finite speed, it's impossible to see things in the heavens that are happening right now. Everything is in the past. And conversely, as they're looking at us, they're seeing us in the past. So if you were on the sun, if you could be on the sun, you'd be seeing us 8 minutes ago. Kind of crazy. So just a word of caution to my 7th and 8th graders who are listening. If you do something bad, that bad thing goes on forever, out into space. You're always doing it, even if you stop doing it. So don't do anything bad. We're getting close now. What is it, 9:13? Okay, we're coming up on about 13 minutes more until maximum. If you're outside, you'll notice it still kind of feels like morning, but the sky is a little dimmer. It's got a weird hue to it. Question was, have I seen Jupiter? Yes, I've seen Jupiter, absolutely. Another question, have I taken a picture of the Canis Major dwarf? You know, I don't know what that is, so I'm going to have to look up that. Telescope's tracking pretty well. See if I can make some adjustments here. That gives us a little more accurate depiction of the sun's color. It's more of a yellow than it is red. Yeah, the sun is so bright. There was a question, can you use any telescope for this? The sun is so bright that even the smallest telescopes work well for this type of observation, for sure. Another question, have I ever seen a black hole? Unfortunately, black holes are so gravitationally dense that they suck light into it. So you can't see light from a black hole. Consequently, you can't see a black hole. But we theoretically know that they exist, usually in the centers of galaxies. Our Milky Way is said to have a black hole or two. They can't be seen, but they can be detected through certain other kinds of radiation. Let me take you back to what the animation says is happening. Let me go back to this animation right here. Okay, so there's what my animation says is happening right there. So we can see that the moon is moving this direction. And we're almost to mid-eclipse. So this is pretty much about as eclipsed as we're going to get. I know it's sad because you want more. I get it. I wish this was a total eclipse. But this is still pretty amazing that we're able to view this. Not only through our telescope, but that I'm able to share it with you guys is really, really cool. Yeah, the eclipse, someone asked, can you only see it in Murrieta? And the eclipse is visible everywhere, pretty much everywhere in North America right now. But depending on where you are, the further south you are, the further north you are, the more partial it's going to be. If you were looking at an eclipse map, you'd end up, let me see if I can draw you a real cheesy picture here. So let me just show you a quick whiteboard here of what I'm talking about. Sorry, I got to get through Windows 11's junk. All right, so here's the United States, there's Texas, there's Florida, there's Maine, and there you go. Sorry. All right, so, here's California right here. That's a bad California. Oregon, Washington, Idaho's here somewhere, right? Yeah, something like that. Well, my Idaho's bad. Sorry. All right, so the actual eclipse path is something like this. If you had an eclipse path drawing, so people in this area would be seeing the total eclipse, the ring of fire. We're down here, so we're seeing it like that. If you were up here, you'd see it like that. And if you were over here, you'd probably get just a little chunk like that out of it. So the further you are away from this path, the more partial it's going to be. And that's why people drive to these locations, so they can set up their equipment and see the best possible totality. Yeah, you got to love my America. Sorry, history teachers. I just totally did you a big disservice there. There we go. Oh, hey, Mr. Van Voris. I apologize for the bad drawing of the North American continent. So we're just about there. We're just about to totality. Which again, if you were seeing this in the path of the eclipse, for those of you who may have just joined, you'd be seeing this. But we are seeing this because we're just a little too far south. And thank you, Pastor Cobb, for joining us. Appreciate that. Glad to all the people who got this link, maybe that I don't know. Thank you for spending time with me this morning in my backyard. Hope you're enjoying it. And there are other websites I know that you could have gone and seen this live, so thanks for coming to my link. If you subscribe to my channel, not that I'm trying to push my channel on anybody, but if you do subscribe to it, every time I do go live for a lunar eclipse or something that's happening in the heavens, you can get a notification and watch. So feel free to subscribe. I don't have any merchandise. Sorry. I only have a few subscribers, so I'm not making any money, nor am I endorsing any products. Okay, I would say we are at mid-eclipse, so this is as much as it's going to get. You can see the shape of the moon there. Again, if I take a picture of this just to show you one more time before you go, if you are going. Let me see. So here's the rest of the moon, so you get an idea of where the moon is. And it's heading in this direction. And so the exit of the moon will look pretty much just like the entrance of the moon, only in reverse. So if you guys would like to hang on, I'm going to hang on for about another 15 minutes. But if you'd like to go, thanks for joining. And I appreciate you doing that. And if I see you soon, I'll talk to you soon. Oh, someone asked what computer I'm using. I'm using a Surface laptop, about a 3-year-old Surface laptop. And it has a pretty decent processor in it. In fact, I bought it just for this reason. Back when we were doing Zoom in the classroom, it did the best job streaming, so it handles everything pretty good. Mr. Davidson, good question. He asked, why does it appear to be going down? Actually, this is, you are correct that the moon moves in its orbit from west to east. Right now in my telescope, east is down. So it's just a matter of the orientation of the scope and camera. Yes, that is the farthest it's going to go. This is the maximum eclipse. Let me go back to the live shot. And there's your live shot right there. That's about 71%. So if you do go outside, it kind of feels weird. My birds are still singing out here in the backyard. I don't know if you guys have any birds. But you may have noticed the breeze has picked up a little bit. Someone asked why the wind picks up. It's because as the sun's heating the surface of the earth, hot air rises. And then when the sun gets covered up, that air mass temporarily starts dropping again. And so it creates kind of a reverse airflow. So a lot of weird things happen when eclipses occur. Hi, Elizabeth. Good to have you on. Yeah, it'll stay right now at mid-eclipse only a few seconds, and before you start seeing more of the sun appear. But it's a good thing it happens pretty slow. That at least allows us to get enough time to view what's going on. Yeah, if you looked at the sun out your window and not directly, if you're not looking at the sun directly, no, it won't hurt your eyes. Just don't look in that direction for very long. But you just don't want to look directly at the sun. Well, hi, my sweet daughter, Heather. I'm glad you're on. Hi, Livy. My granddaughter is Livy, and she likes the moon and she likes looking through telescopes. Hi to all my other grandchildren. I haven't seen you guys say anything yet if you are on. But if you are, I love you all and I'm glad you're watching. Yeah, gamer boy, Alex, I figured it was you. Because only you would ask if I looked outside my window, would it still hurt my eyes? Hey, Sophia. Yeah, I have never been in a full total solar eclipse. I would like to someday, but that's on my bucket list. Again, thank you all for showing up. Appreciate you coming on and supporting the channel and supporting the kids who are watching. That's awesome. Yeah, so if you were in Oregon right now, you'd be looking at this. That's what an annular solar eclipse looks like versus a total solar eclipse, which looks more like this. It's much more beautiful. Or if you were on Mars, it would look like this. Yes, that's actually a Martian solar eclipse taken by the rover Curiosity a couple of years ago. Because Mars's moons are just rocks. So you got to love what we have, that's for sure. Yeah, correct. The moon is not going to cover the sun entirely on this one. It's what we call a partial eclipse. Oh, thank you, my dear wife. She says, my physics teacher, Mr. Day, would be very proud of me. Ha ha. If he could see me now. Yeah, my physics teacher, Mr. Day, he was kind of a rough old guy, but he let me bring home the class telescope one day. I got to hand it to the guy. That was pretty nice of him. That would be like letting Alex take my telescope home. Gee, Alex, I don't know if I would do that. No, I'm kidding. If you look close enough, those of you who are still on with me, if you look up in the top, kind of the top right of the sun, you'll see a sunspot that just got re-revealed there, or just appeared up in here. And as the moon moves across, it'll start revealing those other sunspots that it covered up. Kind of looks like horns, or a smiley face. Let's see, how can we make it look like a smiley face? There we go. Sideways smiley face. Oh, looks like Jack in the Box. Yeah. All right, you all. I'll let you guys that are talking homework and logs on your chat there get back to your homework. I'll expect it done on Monday morning. So I'm going to go ahead and sign off, everybody. Thanks for joining me and taking the time to watch it this morning. I know you have many other things to be doing on a Saturday morning, but have a good rest of your day, and I'll see you guys all on Monday. See you all later. You're very welcome. Guys are welcome. Have a great day. We will see you later. This is Marsalis signing off.